Hello, welcome to my answers for the questions that are asked in experiment number 2. For the first question, when we apply a certain voltage to the primary side of the transformer and we measure the current passing through the to the transformer, we see that in oscilloscope we approximately get 1 ampere, whereas when we measure with the wattmeter we get the value 0.9. And the question was, why was there such a difference? Well, my answer is because when I looked at the oscilloscope's technical specifications in internet, I saw that there was no true RMS calculation feature, whereas when I checked the wattmeter that is used in the video, it was specifically saying that it uses the true RMS and mathematical calculations to calculate the true RMS. And the difference is between the average RMS and the true RMS is that the oscilloscope actually looks at the wave and it tries to compare to the other waves, such as sinusoidal wave or square wave, such as waves like that, and it approximates the signal where then it uses that characteristics to calculate the RMS, whereas in wattmeter what it does is actually looks at all the values of voltages and against the time, and it uses mathematical calculations to sum all the voltage values for over a period and divide it by the period time to get an actual and a true RMS value. So I think that was the difference. In question 2, it asks what does the loss called, and why do we only calculate that loss? Well, the loss is called hysteresis effect, and we actually only calculate this in our situation because we work with 50 Hertz. When compared with other frequencies, it is very low. Therefore, and when we look at the loss what is the loss proportional to the frequency, we see that for hysteresis effect it only proportional with f, whereas the eddy current is proportional with f square. And when we think about it, because frequency is low, the square of it is actually lower, and we can it can be counted as negligible compared to the hysteresis effect. And question 3, why only measured at rated current? Well, it's because when we short circuit the secondary side, we see very low impedance, and when we applied even a little voltage value such as 5 volts, it actually skyrocketed the current. And if we would have increased the voltage slightly more, we might have damaged some components in the system. So in order to be careful, we tried not to compare other voltage values, because the more we increase the voltage, the more the risk we take. And it is because of these reasons that we only calculated the rated current. Thanks for listening to me. I wish you good luck with your midterms.